Good day, everyone. Today we'll talk about moving mainframe workload. And my name is Venkat, and we'll have a pretty interesting session. So let's take a look at it, what people are really doing. And it's no-brainer that everybody's today thinking about modernization. There's a huge motivation and driver for it. I'm not sure if there is any organization which is not thinking about modernization. And they have a mainframe. But if you take a look at the factors, people are worried about cost, how much it costs today to run things on the mainframe, and how can I reduce it? At the same time, people are thinking about how I'm going to innovate, because you have a huge amount of competitive pressure. The companies that are on the mainframe obviously are very established companies, and the newcomers, the new startup coming up, they're coming up with the newer technology, great ideas, great innovation, and they are to be dealt with. And how do you deal if you don't have innovation and if you don't have a cost control? I mean, you can absorb some of the cost, but you still need to figure it out what you're going to do. But if you take a look at it, there is a risk involved in every one of it. You have a working system, a system that works great, but then there's a risk there of changing anything in that system that is so complex and it's doing your mission critical application. But you also have a risk of not doing anything. But at the same time, what if you're able to scale your operations? If you're able to scale in a cost-effective way? I think that can mitigate some of your risk. But then how you do it in a cost-effective way, that's the key. And that's what we're going to talk about in today's webinar. Our focus is going to be how you can leverage the cloud to do that. If you take a look at it, where the industry is thinking, people are thinking very strategically. They're thinking, we're going to take our processes on the mainframe. We're going to migrate, modernize all the critical mainframe application. We're going to take our data, make it scalable and flexible in the cloud environment, make them cloud native, maybe preserve the core functionality, but definitely preserve the business value. There are people we talked about in the past that you have multiple ways to do things. There are people who have a very noble idea saying that all the legacy is crap. I'm just going to rewrite everything in a new way. It's going to be very efficient. But then it's not very practical. It's a very noble idea, but it's not practical at all. Because think about it. Something in your environment that was written for 30, 40 years, the business requirements were gathered for so long and have been validated for so long. Do you really think you can get it done in 3 or 4 years, rewrite everything? And even if you could, are you going to validate all your results? Is your business ready to validate and certify everything you have done? And what if you go back in business and say, I'm going to take 10 years to modernize everything? Is your business going to fund you? Is there really a return on investment? So that focus has a little bit of flaw. But that's what we want, right? How do you do it? There's another option is you can just lift and shift, move things away. But then you also have a risk. You have to make sure you're really moving the needle. Are you really moving the needle? So those are some of the challenges that comes with the focus. In today's webinar, we're really going to say CloudFrame perspective. And of course, we're going to give you modernization, migration into the cloud. But more importantly, what if we also give you a solution that's very practical, allowing you to move or bust your mainframe workload into the cloud, make you more scalable without taking the risk. You have a lot of critical application running in mainframe COBOL application. You want to be scalable in a cost-effective way using your cloud environment while preserving the core functionality and business value, but not touching your data. And that's the key, because the moment you touch your data, you open up the whole can of worms. Data is critical to everything, and data is so integral and so tightly coupled with every one of your applications. Any changes presents a huge risk to your environment. Can you really do it? And with CloudFrame, we'll show you how. So what's the impact of moving your workload? I think the number one thing people look at on the mainframe side of it, what's my cost? And there is a whole bunch of professional, dedicated team who does capacity analysis, try to figure out how can we reduce your MSU, the CPU, which is directly linked to your cost, licensing cost or the mainframe cost. If you're running on a 4-hour rolling average model on the mainframe, There is a bunch of people who specialize trying to figure out how I can move things from one 4-hour rolling average peak to another one, reduce the cost, flatten the curve. How do I lower my software licensing cost like MLC? Or if I cannot do it, is there a way I can do a cost avoidance? How do I increase my capacity without, just putting a dent on my budget? I really don't have a lot of budget. And what if I create a white space? What I mean by white space is today you have a mainframe that is a shared all system where everything is running at the same time. Okay, you have a lot of LPARs. You can distribute things in your Sysplex environment, but they still make you feel like it's one mainframe. And everything is in the same mainframe. You have critical application, non-critical application. You have high CPU application, low CPU application, compliance application. Everything is running in the same environment. And if somebody gives you a capacity, extra capacity, and allows you to integrate the cloud environment with your mainframe, and you have an ability to take things out, move things out of the mainframe environment, temporarily bust it into the cloud, what you get is a lot of white space. And that white space you can use to improve your critical functionality, to make them run faster. So there are multiple ways to look at your mainframe workload, and there are multiple advantages. Some of them will give you an immediate cost saving. Some of them will give you a cost saving down the line. Some of them will give you cost avoidance, and some of them will just give you high performance for your critical application. So why moving workload into cloud is a reality nowadays? Now, first of all, back a few years ago, people were still thinking can I trust cloud environment? It's a public cloud environment. What is the risk? Are there any security problem? That has completely changed. It's completely turned around. There's so much of trust into your cloud environment. Pretty much, I have not seen a company that's really saying, I have nothing in the cloud. Very, very few, maybe none. And public cloud vendors are nowadays competing into the mainframe space, trying to figure out how we can get more and more mainframe workload moved into the cloud. And this is to do with every one of them, whether it's Google, whether it's AWS, and Azure. I specifically point out Azure because we have a pretty good relationship with Microsoft Azure environment. And we have a customer who are moving their workload or busting their workload into Azure environment. There's a lot of interest in there. And it is a reality. The mainframe and the cloud can really live together now. You also address the volume of technical debt that's coming on the mainframe. You're trying to figure out how do you modernize. At the same time, you're trying to figure out how do you contain the cost. And these are two separate initiatives, but they all kind of complementary to each other. The biggest problem is how do you leverage your data? We talked about mainframe being a shared all environment. So people for long have tried to take their read-only data, move it into data lake, run all their read-only processing from the cloud, comes up with a lot of peril. It works. People have tried it successfully. There are a lot of examples to do it, but then it also has a lot of problem. You're duplicating your data, and then start duplicating your data, you start to worry about how do you sync it up? Where is the golden copy? And sooner or later, people forget where the golden copy is, and the data is getting upgraded in two different places. Now your data is getting out of sync. So there are a lot of things that needs to be thought through by doing it. And what about the workload that is update, where the updates are being done? Can it really be done in the cloud at the same time, having your data on the mainframe? What's changed right now is there are automated tools available in the market. So let's talk about what CloudFrame can do for you. And then we'll talk about the best practices. With CloudFrame, we have done a lot of work, and we have made this a reality where your cloud and a mainframe environment can live together. And you can leverage the best of both, knowing fully well that your mainframes are going to be there for some time. It's not easy to completely remove them and replace them and just get out of them. It's a long journey. No matter how much we wish for it, it's going to take some time to happen because of the risk and and everything else involved with it. So while they're there, how can we leverage the advantage of the cloud that it brings? Because what cloud gives you is an ability to shrink as little as you want, and ability to expand as much as you want in a very cost-effective way. That's the whole idea about it. On the mainframe, you can't really do it that effectively. You can, of course, say, Yeah, I have on-demand availability. I can call IBM, add more engines into my mainframe, but then you still have to pre-plan this. You have to plan it in advance, what you're going to do, how much capacity you want. They're very expensive to do it on demand. So you really don't want to do it. And if you do your planning in advance, 3 years in advance, and project your capacity that I will need 15% more capacity, I need to pre-purchase it. There's a very specialized team involved in that, and it's just a very expensive process. It's not something that's very intuitive and easy to do. But with the cloud, it's very simple. You have a huge advantage in scalability. So the best thing you could do if you have your mainframe and the cloud working together, and cloud gives you a scalability option, which is very elastic, very solid, very scalable, very cost effective, you got to define your objectives and measurements. You got to figure out what workload and when you would like to move them. For example, you have a special season, maybe tax season, you're a bank, or maybe retail season or Black Friday season, where there's all of a sudden there's a huge amount of workload. Or maybe there is some unplanned activity, something happened in the world stage, and then all of a sudden the volumes are just spiking up. What are the applications that you really want to leverage cloud at that point? Or maybe on a daily basis, maybe during your peak hour in a nightly batch cycle, maybe some of the workload can move into the cloud. So those are the things. Once you define your objective, you define your measurement targets, you need to figure out the right application, a candidate that is a good candidate for moving or bursting into the cloud. And then you start doing this incrementally, because that will give you confidence and that will avoid the risk. It's a huge risk mitigation technique when you start doing things incrementally. And good thing is you can always come back to the mainframe with mainframe and then rerun your workload on the mainframe at any point of time you want to, or bust into the cloud when you want it. At some point of time, you might also have to think of your architecture and your process decision, because once you start doing it, you're going to see that there's a huge potential here. And then you start to think that architecturally, what decision that you want to make it a long-term reality and make it even more effective. So on the CloudFrame, what we do and how we move the COBOL workload. So take a look at on the left side of the equation. We talked about mainframe being a shared all system. Everything is running together. Doesn't matter how many L parts you have. You have your critical jobs, your time-sensitive jobs, your non-revenue generating jobs, your end of week, end of month, end of year jobs, end of stream jobs, your online transactions, your CICS transactions. Everything is happening at the same time on the same system. You can't really decouple it. And people have tried. How are you going to bust your workload into the cloud? So one thing you can do today is you can install CloudFrame, and CloudFrame will give you an ability, a choice to keep your workload on the mainframe or move it on the mainframe, and which workload to move and when to move and all those things just makes it super easy. And we'll go through each one of those examples one by one. For example, what do I mean by low priority jobs and how can I move it to the cloud? What about end of week, end of month, end of year jobs? What about end of stream jobs? And what do they mean? Once you move them into the cloud, they're simply a bust. That means they're not really, they're just leveraging the cloud capacity at a very effective scale. And the cloud, and as you know, that you can scale as much as you want and shrink as much as you like, bring workload back onto the mainframe. But what you have done is, firstly, you have created a white space on the mainframe. That white space can be used by your critical job. They can run faster. They don't have to get swapped out, or they don't have to compete for resources that other jobs were taking at the same time. It also reduces your 4-hour rolling averages if you're running on a 4-hour rolling average licensing, thereby reducing your software licensing cost. And even if you have a different licensing model, you can still do a cost avoidance. By creating this model, what you know is when time comes for renewal of your licensing agreement, you're in much better position to figure out how you can add more cheaper capacity rather than simply saying, yeah, I need more capacity, more space on the mainframe and pay through the nose. So it gives you a ton of advantages by doing this. What you have done is you completely mitigated the risk, because you can always run it back on the mainframe. What you also done is you also bought some time to think about how you really want to modernize your application. And maybe take a few applications, redesign it. What is your data dependency? Buys you time. And you don't have to go to business for funding everything, because now you have created a self-funding model where a lot of the funding that's coming out of the cost saving, you can route it towards your modernization effort. So let's take a look at the use cases. There are good use cases that you can start leveraging to begin with. And as we said, once you start doing it incrementally, you're going to find that you can actually have more and more use cases that you can run it this way, burst into the cloud. And you can also make some architectural decision. And then you can leverage, as you make architectural decision, just leverage more and more capacity on the cloud. So we're going to talk about sequential batch processes. We're going to talk about last step processes, non-revenue generating processes, low priority, but high consuming CPU processes. Let's take a look at the sequential batch process. And you're going to find a ton of use cases. You have sequential files. Almost all the organization who use sequential files, like QSAM files, they are reading the data sequentially or writing the data sequentially. It's very rare that they're going to go back and rewrite a QSAM file. Very rare. You also have a lot of applications you'll find that are doing DB2 cursor type application. They open up a DB2 cursor, just open the floodgate, do the processing, read a file, compare a file, maybe write something else, write into MQ. But majority of your processing, majority of it is happening sequentially. And the sequential processing has a lot of advantages, especially when you want to burst into the cloud, because the sequential processing can do prefetch, and that's where CloudFrame can help and can auto prefetch your data and move your workload from COBOL into the cloud. Basically, CloudFrame internally will convert it into a Java and run your JVM into the cloud. And all your processing will still be very effective, but it won't consume the amount of CPU and amount of resources it was consuming on the mainframe. And you don't have to compete with those resources on the mainframe. So they are a really good candidate, and you'll find a lot of them there. CloudFrame can help you identify those candidates. We also have a processes scanner that you can run to identify that. Then also take a look at the end of stream jobs. If you have a job, which is the last job in your batch scheduler, it doesn't have a successor. What you do here is you don't have to worry about syncing the data back on the mainframe. Maybe it's a report that you're anyway transmitting out of the mainframe. Someone else is reading those reports out of mainframe. Why do you want to pay for that process to run on the most expensive platform or most expensive CPU on the mainframe? Simply burst into the cloud. Run it on the cloud. It's a great place to be there. It generates all the reports. We have customers. We have one customer who is using almost $14 million worth of processing and moved everything into the cloud. Very cost effective. All this reporting application, there is no reason for them to be on the mainframe. Then you start thinking about your non-generating applications. You have a lot of application in your organization that are really not contributing to the revenue of your business. And revenue is the most important thing in your business. But those processes are required. Think about the compliance. There are a lot of things that you must do for compliance reason. You might have 30 years of data that you might scan through and figure out some patterns or do something, maybe do fund performance report or whatever it is, but they're purely needed for compliance reasons. They are not contributing to your revenue growth, but they are expense item on your book. Is there really a reason why you want to run that on the most expensive platform? The statement generations, the print jobs, the print finish jobs, other reporting jobs, data sync jobs. Many a time you have a lot of processes that are just syncing up data to be used by other applications. Anytime this has happened on the mainframe all the time, because people back in those days were not using agile technology. Maybe even today they're not using agile methodology on the mainframe. You have some requirement came in, and your business says, no, I need it in the next 4 months. And you look at it and say, there is no way I can get it done in 4 months because there is too much of interdependency. Not everybody is ready to do it. I've seen it all the time where people create a copy of your databases, copy of your files, And then they just do it, give the business and get it done in 4 months. But now what you have done is, now you have an application, you have a copy of the data on the mainframe, a complete different application that should have really, if done correctly, should have leveraged the original source. So now you need to figure out how you're going to do the data sync between the two applications. And there are a lot of application in between the immediate application to take care of that. When you start digging into it, you're going to find quite a lot of processes that are non-revenue generating processes, and it's costing you a ton of money. Best candidate to move it into the cloud busting. Run it on the cloud. Really good candidate. Also think about the high CPU consuming application. This might be a low priority job. They get swapped out. They run forever because your critical job takes over all your time on the mainframe. They're not running on the mainframe anyway because your workload manager has swapped them out. But they are competing resources on the mainframe. A very good candidate to just push them off in the cloud. You have a lot of capacity available in the cloud. So these are some of the use cases that I have given. And I'm sure you'll find a lot more use cases when you start thinking and start looking at your application. And the cloud busting is a great technique to leverage and gives you a really good cost-effective scalability option. Not just, you don't have to be stuck with the only few options left on your mainframe, which is basically call IBM, have an on-demand CPU upgrade, or you plan your extra capacity in advance and leave a lot of extra capacity unused on the mainframe. You no longer have to do that. So David, with that, I want to see if there is any questions in the audience that I want to answer.
Yeah, we have a couple, but let's go ahead and progress to the FAQs. I think you've obviously hit on a lot of information there, and I think going back to one of the last points that you made around best practices and thinking about architectural decisions and process decisions, when we look at the opportunities that the use cases provide, I think that's where some of these questions are coming from. But let's go ahead and answer some of these that we have on the screen here. I think one that comes to mind for everyone that talks about modernization is data. What about the data in this scenario? Can you tell me a little bit about how CloudFrame handles that?
Data has always been the sticking point, because like I said, mainframe being shared all system, everybody is dependent on the same data. You have a lot of application, and not every application is ready to move out of the mainframe. Maybe some of them are a black box. Maybe, people just don't know what it does, and you're afraid. What if you just yank it out? Will it work? Will it not work? And if you don't, will your data get out of the sync? I think in the past, people have been thinking about data first strategy, and they're saying, well, let's move all our data. But actually, it's a really risky strategy. It's a good strategy in theory, on paper, really difficult strategy to execute. Anytime you touch your data, like I said, it's kind of worm. So what CloudFrame we do, we says, no, you leave your data in place. If you're using DB2 on the mainframe, you're using MQ. MQ has an option. You can cluster your MQ. DB2 on the mainframe, you have QSEM files on the mainframe, vSEM files on the mainframe. What you're going to do, how I'm going to move to the cloud. One option is you can obviously move the data onto the cloud and run everything from there. But then what happens, how you're going to sync it up? We talked about interdependency. So CloudFrame gives you a great option where you can leave your data on the mainframe, and CloudFrame will give you a very efficient and cost-effective way to sync up your data between your cloud execution and the mainframe application. And sometimes, especially if your application is the last one in the stream, really there is no reason for you to sync back on the mainframe. So for example, you generate a ton of reports, but the report is dependent on the data that's coming off mainframe, which the previous process has upgraded it. And obviously you can't use data lake because your data lake data is probably 24 hours old, or maybe it's not real time. You want a real time data to do your processing, but your report generated doesn't have to go back to the mainframe. So CloudFrame will give you every options, whether you want to keep your data on the mainframe, you want to move your data into Azure, for example, in a blob storage and use that blob storage, or you want your output data generated from the on the cloud synced back on the mainframe. Pretty much when you run this process with CloudFrame, your mainframe guys will see no difference. They will see the process as if it ran on the mainframe. Your operator will see it's running on the mainframe. Your job will be on the mainframe. Your data will look exactly the same before and after, but there won't be any CPU consumption on the mainframe. And this is a great strategy because now you reduce the one big risky equation of data. It gives you time to start thinking how you're going to modernize, and you don't have to rush into that decision.
Great. Thanks, Venkat. I'm going to paraphrase a couple of questions that we have here around basically, CloudFrame has talked in the past around using Java as being the target environment for converting COBOL and getting that to run off of the mainframe. How is the source code maintained now that we're talking about cloud bursting and moving those workloads? Do we have this movement into Java that the teams need to be worried about?
It's a really good question, David, because what happens is when you start your modernization or whatever journey you start, you obviously think, when can you, for example, if you decided you're going to decommission your COBOL and move it into Java or .NET or whatever it is, first question will come to your mind is, how are you going to handle the changing business requirement? You can't stop your business to keep giving you requirements. And when that happens, you have two sources. You have a source that's in the COBOL, it's actively being maintained, and you have a source that's in your Java. It's very difficult to sync it up. And that's where the problem comes in. And CloudFrame gives you a great option. Well, the easiest way to do using CloudFrame is keep your COBOL sources where they are. They might be in Endeavor, they might be in Changeman, they might be in ISPW. We give you a simple integration point where CloudFrame, every time you make changes to your COBOL source code, a near real-time copy available in Java. And usually when people do changes, obviously, you're going to do testing, you're going to move into staging, you're going to move into production. Do the same way you do. Don't change your process. What it does, it reduces your risk. Now your Java processes are guaranteed to be in sync. Whether you run it on a cloud, you have one VM, you have Kubernetes, you have Docker containers, you have thousands of containers coming up, doesn't matter. They're all synced up. But you're maintaining COBOL. Once you have decided what your modernization strategy be, whether it's you want to rewrite it, whether you want to use CloudFrame to convert it completely into Java, whichever strategy it is, you're still going to be safe. There comes a point when you say, I want to decommission my COBOL program, you are in a very good position at that point. And even if you decide to continue running in the COBOL, you haven't really added additional risk because CloudFrame is taking care of syncing up your COBOL changes to your Java changes in real time.
Okay, thanks. Similar to that, there was a question around where the workload is being moved to. And I think that's the question here that we have on our FAQ list of where can CloudFrame burst the workload? And I think that's related to the Java question.
Yeah, I think this is one of the decisions CloudFrame has made, that we're going to take your legacy COBOL application and we're going to move it into a JVM. And the reason we picked JVM is mainly because it gives you a ton of choices. You can run the JVM on the mainframe itself, on ZOS. And why would you do that? Many reasons to do that. Number one is your data is right there. Your proximity is right there. And your Java workload become 100% zip eligible. So you have a huge amount of cost saving. But is your really zip scalable? Or is zip any cheaper than the processing on the cloud? Maybe, maybe not. Now, it really depends on how you have done it. If you are using one of those hosting providers, for example, T-System or Kyndryl, they might charge you on the zip capacity. So is it going to be cheaper than your cloud? I don't know. It really depends on how it has been set up. Or if you're not using it, the zip seems to be a cheaper option. But then again, it's not a scalable option. It works. It works for some application. But if you start taking a look at it, your one mainframe CP engine allows you to buy 2 or at most 3 zip engine. So your zip capacity is tied to how much general purpose processor engines you have. And your zip capacity is also used by other vendors. For example, SyncSort, maybe DB2 is using a part of it. So you're competing your zip capacity. And what about multi-threading in Java? Can Java really leverage the multi-threading and run it on multiple zip engine the way it does on the cloud environment? I think that's one of the questions. So what you want to do is you want to have a mix. Maybe you keep some application on the mainframe ZOS JVM. CloudFrame will give you that option, and move some of them, and majority of them, I would say, into the cloud. Bust it into the cloud. Let it run on the cloud. You have a huge scalability. So you have a great choices. Run it in COBOL, run it in JVM on the mainframe, run it on the cloud.
Good. Similar to that, we have a question around, I'll just paraphrase here, stats on how cost efficient it is to move the workload of the mainframe to the cloud. So I think this is around, how much CPU, what's the decrease in GPP usage, that type of thing.
Yeah, and pretty much majority of your GPP usage is offloaded. Why? Because you're not doing any of your processing on the mainframe. Now you do have I/O involved, because what CloudFrame is going to do is going to take your data and sync it up back to your mainframe data. Now, this is purely an I/O operation, so there will still be a little bit of CPU involved, but it's very little. So you're pretty much offloaded your 80% of the cost of your general purpose processor into the cloud. Now, what about DB2? You also have a DB2 workload. Is your DB2 workload gives you any saving? And yes, DB2 workload, when it comes from the Java JDBC, it becomes zip eligible. And all of a sudden you have at least 60% saving. I have seen it go all the way to 80 to 85% saving. And we have a great technique where we can actually give you a much higher saving than you would normally go through a JDBC, full handwritten JDBC application versus CloudFrame application. So the cost saving is enormous. And many a time you're going to see, you will really no need for you to sync back your data on the mainframe. For example, a report that is going to go out, you're going to FTP it from mainframe into distributed for something else. There is no reason for you to sync it back on the mainframe. Leave it on the Azure blob, leave it on the container, data container, leave it somewhere else. You can even further save.
Okay, good. We had a follow-up question around the source code. Just wanted to verify. The question was, so the source code will be maintained in COBOL and not in Java. So can you just confirm that for the attendees?
Confirm, absolutely. You want, because this is a practical problem that you can't just big bang decommission. You say, I'm going to decommission all my COBOL today, Friday, and from Saturday onwards, everything is Java. Just think about the reality of this. It's really not feasible, right? You have hundreds and thousands of programs. You can't really do that. So you're going to have a business requirement coming in. You're going to have to maintain your COBOL for quite a reasonable amount of time. And that's why CloudFrame gives you a practical way to do it. You continue doing what you're doing, continue maintaining your COBOL program. You do need to do, it's a one-time effort where you need to have a new processor group in Endeavor, or you need to have a minor addition in a new processor group or new changes in your change management system, where one step will be CloudFrame step. Say, for example, today, what do you do when you compile your COBOL program? Under the cover, your change management system is doing a precompile if it's a DB2 program, translate if it's a CICS program, sends it to compiler. Maybe it's using a integrated compiler. Then it's doing a bind. So there are a lot of steps in there. All you have to do is add one more step at the end of it called CloudFrame step. And we have a full documentation. We'll show you how to do it. It's really easy to do. Once you do that, all you have to do is, as a COBOL programmer, you really don't have to worry about. You simply maintain your code in COBOL, check in your code into your favorite change management system, and just make sure you use the right processor group or right group, which will have a CloudFrame step. So at the end of your compile, you also have a Java compile added on top of it.
Okay. So during the course of the presentation, we talked a little bit about functional equivalency, and one of the questions that we always get is, why is that important, and how should that be viewed in the context of moving workload off the mainframe?
That's the biggest problem people will face, is the functional equivalency. The reason is all the methodology used on the mainframe to calculate do all your calculation is very different than you normally do. A simple example is if you have a compound interest calculation, and you take your calculator or take your Java and write a code which does a compound interest calculation, you're going to get a different result than when you write a code on the mainframe. And the results on the mainframe can vary depending on what data type you chose, whether you used COM3, what was your scale, and also depends on type of compiler options you use. Did you use trunk bin, trunk op, trunk standard? Did you use arith extend, arith binary? There are numproc, PFD, different type of options you use. Your calculation will vary. And why does it matter? Well, say, oh yeah, it's only a fraction that changes. It matters because when you run this as a part of the report, and if you have given your customer a report of fund performance or anything, for example, last month when you did your calculation on the mainframe using COBOL, and you give your calculation done through Java, and even if it's slightly different, when you run through millions of records, your difference will multiply, become enormous, and it will look like a bug, even though your Java calculation might be right, but it's not the same calculation what your business or what your customer was used to looking at. So it's very important the functional equivalency be maintained and maintained the same way they were done in COBOL. The rounding, the calculations, the compilation options, everything is impacted. If you handwrite it, you're going to struggle.
Okay. That's a very good summary. I think that's an important piece that we all need to keep in mind, is that whether it's right or wrong, it needs to be the same. Okay, so one of the things that was asked is around the duration of projects, and I know that we just published a case study where we had done this with a pretty large bank where we were moving some workload for them. Can you talk about what our typical project looks like when we go into this type of moving mainframe workload project?
Yeah, absolutely. So I think the biggest problem you're going to find in the mainframe workload is figuring out, what process what are a good process. The second thing you want to figure it out is, can you move everything into the cloud? So for example, if you have a program and program has a call chain, and you have a 20 program in the call chain, are you able to move all the 20 program into Java using CloudFrame? If you do, you're going to get a much better performance. But if you don't, you might say, oh, well, I have a date calculation program that's written in assembler, or I might have an EasyTree application, or I might have a third-party software in the mix. It calls another program. There is no way I have a source code available for that. So what happens in that scenario? Well, in that scenario, CloudFrame will make a call to your MVS on the mainframe, will run it as an MVS under MVS batch address space, and come back to the cloud. Might be okay if you do it once, twice. You really shouldn't do that in a loop. You have a zillions of record that you want to process. You want to make sure it's done the most efficient way. You move the entire call chain into the cloud and run it. And that's a critical decision, because you need to figure it out. If the program that you do not want to move in a call chain, you have in your list of 20 program in a call chain, and you say, I'm only going to move 19 and bust it into the cloud, but I'm going to leave one on the mainframe. Make sure that one is called only once, or maybe at most 10 times, not in a loop. So the duration and the staffing really depends on your initial assessment. Once your initial assessment has done, things will move really fast. You should be able to do this in a 30 to 90 days window.
Wow, it's pretty quick. Okay, well, we're getting to the end of our time. I'd encourage anyone else that has a question to go ahead and submit them. Venkat, if you want to bump us forward one slide. Venkat, thank you very much for taking us through this important information today. I think it's very informative around how the progress is being made to move mainframe workload to the cloud, and our ability to burst that so that we're getting the scalability of the cloud and not just relying on mainframe increases and redoing contracts there with IBM to increase our mainframe environment. So I want to thank you for taking us through that. We've come to the end of our time, and I thank everyone for participating with us today.